This video is going to cover two concepts of the use of a voltmeter for measuring resistance. So the use of the ohm meter in the digital multimeter. One of the first things that we have to understand is that some multimeters you can zero out and others you cannot. So if I'm looking at the multimeter on the left, it is set to measure resistance. It's on the omega symbol. And when the leads are not touching, it's showing open loop. And that means there's no continuity between these two, between the two leads. But if we take and connect those two leads together, we'll see that it is measuring 0.2324 ohms, so 240 milliohms of resistance. It's very, very low because those wires are connected together, and that's just the internal error of the machine. But if I want to take a very precise reading on a circuit, I want to know what that reading is first to make sure. This is also a lead check. If there was a problem in one of my leads and it had a lot of resistance in it or a bad connection where it goes into the meter, then this test would show me that I probably have a problem with one of my leads. So the next thing to be aware of is what is actually happening when the meter is doing a resistance test. And we talk about what's the best test to do. Is it testing for resistance, checking the amount of resistance in the circuit, or is it doing a voltage drop test on a live circuit when it's got a load on it and it's working? What a DVOM or a digital multimeter is actually doing is when we set it to resistance, it is outputting a voltage on one of the leads and seeing what it gets back on the other lead. So it is doing a voltage drop test, but it is doing it through a circuit that must be unpowered so that it can check to see what kind of a voltage reading it's getting. And to prove that, I have another meter over here that's set to a 60 volt range, and I am going to connect the red lead to the red lead and the black lead to the black lead. And you can see that at this stage, the meter that's set to measure resistance is measuring 10 mega ohms of resistance. And that's actually the specification that you want for a multimeter measuring voltage. Is you want to make sure it won't pull down a computer circuit or something. So it needs to have a very high level of resistance on its circuit so that it doesn't cause a problem on a computer circuit. So that's good. But what we also see is that this meter is outputting a voltage. And right now this meter is set to a specific range, but I'm going to put it back on auto ranging. Hang on just a second. There, it's set to auto range. And I'm going to make these connections. And so you can see that this meter, the OTC meter here on the left, is putting out about a half a volt, 0.63 volts on this circuit. And that will change between meters and what setting they're on. And so here I am set to manual range for measuring ohms. And now this meter is outputting 2.6 volts. That's significant. So what the meter is set to for measuring resistance will determine what output voltage it is. And this is where you can get into trouble, because some meters I've seen as much as 7.5 volts output. And if you go trying to check some circuits with 7.5 volt output, you can get some really nasty surprises or even damage a piece of equipment. So know what your meter does. So that's the first step. Zero and know what it outputs when you have it set to a specific range. So the next thing we're going to talk about is a resistance test really good? Can a resistance test find problems? So we zeroed this meter and we got a baseline. of 230 milliohms or 0.23 ohms. And we now have this section of wire here that I'm going to demonstrate the reality of testing resistance on a wire. Now, a lot of service information will have you do this. So there's 10 feet of wire here. So I'm going to go from the positive lead with one lead to the positive lead on the other side of this wire, and I'm going to get a measurement. And we're seeing 0.29, 0.28, and remember we had 0.23, so I have 0.06 ohms of resistance on that wire if I do the math. Now I'm going to check the other side. So I'm going to move the lead over, and I'm going to check the other side, and you can see that we have basically identical readings, 0.29 to 0.30. So if I subtract the baseline of 0.23, 0.24 for that, I have 0.06 ohms of resistance. Now, is that wire good? If we only test the resistance of the wire, we may think that this wire is good. But let's take a look at what's really going on with this wire. This wire has been intentionally damaged. And if you look at that, you can see that all but a few strands on that wire have been cut. The insulation was peeled away and this wire was damaged. And so with the very low output of that multimeter, it cannot detect that there's a problem with that wire. But if this wire was being used to run a device that was drawing a higher current, required more power to operate, that would heat up and cause a drop in voltage, which would cause a drop in output. So this is why we say that the best way to test a circuit for integrity is with a dynamic voltage drop test, or to look at the circuit in totality. What is the voltage? What is available to the device? And what is the total power output or current flow in the circuit? And that's the only way you get a complete view of what is going on with an electrical circuit. So resistance testing or continuity testing has its place, but voltage drop testing is where you would find problems like this.